everybody. Came to my attention to take a look at this problem from my math lab. And it involves the central limit theorem, and which I do think is a complicated idea, but I'll go through it in the context of this question. So it says, mean percent of childhood asthma prevalence in 43 cities is 2.41%. Okay? Okay, and it says, say we take a random sample of 33 of the cities. So there's like 43 cities. We know what the mean percent of childhood asthma is among those 43 cities, and then we just randomly pick 33 of them. That's what we mean by random sample. What's the probability that the mean childhood asthma prevalence for the sample is more than 2.7%? Okay? And here we are assuming that the standard deviation is 1.26%. Okay, so just to wrap your head around what's happening, so we got these 43 cities and we know the mean for the 43 cities. We take 33 randomly and we average out those, and we wonder, okay, what are the odds that the average among those is going to be this or that? Okay, specifically, what are the odds, what is the probability that the mean childhood asthma prevalence for the sample, 33 cities, average them all together, is more than 2.7%. So here's what we know about this situation. Okay, any sample you take of size 33 from those original 43 cities that we then calculate the mean of, as far as childhood asthma prevalence goes, it will have a mean that's identical to what the original sample it came from was, which is 2.41. And it will have a standard deviation of sigma over root n. Okay? So, in other words, when I was told that, we're going to assume that sigma here is 1.26%, they know that somehow, or they're giving that to us, then I'd say, okay, well, the standard deviation of this sample, because, if I take a sample of size 33 and I find the average childhood asthma prevalence of it, that number might be all over the place. And the standard deviation is our measure of dispersion among all those possibilities. But it's going to be 1.26 over root of sample size, okay? And I need to update this number a little bit. That number is 0.2193378, 2193378. I need to get as many digits here as possible. So like that. Okay, that's what that number is. So I know for my sample, I know what the mean is, I know what the standard deviation is, and I know I'll have a normal distribution. So that's the big one. That allows me to do calculations of probability. So then when I'm asked, what's the probability that we take a sample as described above with a mean more than 2.7? And that's just like saying, if I had a normal distribution with this mean and that standard deviation, what are the odds of the random variable being more than 2.7? So in that case, I can just open StatCrunch, okay? And if I want to access the normal probability calculator, it's under Stat, Calculators, and then Normal, okay? So I open that, and I put in the mean, 2.41, and I put in the standard deviation as calculated. And I said, what are the probabilities that, here's what this is asking, my sample of 33 has a mean more than 2.7. That's what this is saying. And it's 0.09305. So it's like 9.3%. Okay? So, all right, I can go then and answer my question. Because here's my question. What's the probability, right? As described, 0.0931, round to 4 decimal places. And if I interpret that in terms of a percentage probability, then about 9.31% of samples of 33 cities will have a mean childhood asthma prevalence greater than 2.7. Okay, so that's the central limit theorem. It has a lot of layers to it. And I think what might make it hard to understand is that what we're saying is that we're trying to make predictions, probability calculations about a sample that we calculate the mean of. Okay, so anytime you see a question and it says, okay, we have this or that scenario, but we're going to take a sample of size whatever, and we're going to calculate the mean of the sample. You'll be dealing with the central limit theorem, okay? All right, in that sample, the mean of the sample will have its own mean and its own standard deviation and a normal distribution, and it's from that entirely that we can do calculations on the probability of the mean of the sample being whatever you want. Okay, so there's some depth to that for sure. I think there's a lot of concepts intertwined in the central limit theorem, but that's how it works. Have a look at this question on my math lab or any like it, and let me know if you need any help.